These are the solutions for practice test number 1, problems 11 through 20 on the no calculator part, and on your lesson number 5 in test prep. So anytime you get a question about a system of equations and you want an infinite number of solutions and what has to happen, the concept is that one of the equations has to be a perfect multiple of the other. So obviously this bottom row is going to be a multiple of the top row. So you need to figure out what did the top get multiplied by. And so obviously the 4 to 16, that number would be 4. So it produces 16 and then 4 times 2 or negative 1/2. 4 times negative 1/2 would be negative 2. And then 4 times 1/4 would be 1. So A needs to be 1. Again, the concept has to be that one row is a perfect multiple of the other. Problem 12. So what I do in this case is just start writing down a little table. So your X is time, and then your Y is fuel remaining if you burn 1 gallon per hour. So starting you have 12, and then after 1 hour, 11 gallons, after 2 hours, 10 gallons, so on and so forth. Which of these functions produces that table? And it would be the 4th function. Problem 13 is a great problem to demonstrate the concept of the numbers game. So you're probably looking at this and going, oh my word, what is all this? I understand. So you really want to focus on these circles with no highlighter in them, because that's probably the best way to go about it. The problem is you have to start with 3 as your variable choice, because 2 gives you 2 answer choices being 6, and we can't have that, so that's all the yellow highlighter. And picking 1 puts zeros on the bottom of the fraction, so we can't have that either. So note that 1 and 2 are not possible numeric choices for X, so you have to start with 3. So start with 3, and you go through this and you figure out what all your answer choices are. Those would be 4, 8, 18, and 16. And then go to the top, run 3 through, and then whatever A is, it's got to match one of these. So putting 3 in, you get 2 times 3 squared, which would be 9. 2 times 9 is 18. Over 3 minus 1 is 2 on the left. And then 2 over 3 minus 1 is 2. So 9 equals 1 plus A. So A must be 8. Now that isn't too bad to do that. And that would be my suggestion. Again, the hint is, or the clue is, that your answer choices are all variable expressions. Okay, so note that that's what you need. This is here the way of working it through algebraically, which I'll let you look at that, but I'm not going to take time in the video to explain that. Problem 14. So we are confronted here with drawing this segment in, which would be another radius of 1. And this would produce a 30, 60, 90 right triangle. Okay, and so how do we know that? Because the diameter is 2. So we know this is 1. And if the length of RT is 1/2, so based on that, so this is 1/2 and this is 1, so half the length of the hypotenuse is the shorter leg, so that would tell you that this is the 30-degree angle. So rules of 30, 60, 90-degree right triangles. And that would make X 1/2 times the square root of 3. So square root of 3 over 2 would be X. And so you wouldn't need to do all this. You would just need to know that the square root of 3 times the shorter leg is what X is. And so then we want what QS is, so you multiply square root of 3 over 2 times 2. So knowing your 30, 60, 90 right triangle rules would save you all of that work. Problem 15, this is one of these that I'm going to say don't spend a lot of time on, take your best guess, because if you're not real good with circular trig, you're not going to get this. And I just realized that I broke the rule here. I picked a number, so this is the numbers game because you have variables in your answer choices. I picked x equals 0, and it worked, but you're not supposed to actually do that because x has to be larger than 0, but less than 90. So no calculator part, 0 did make it work, but you have to know in picking x equals 0, you have to know what cosine of 0 is to start with. And then you need to know what cosine of pi is to start with, and that's -1. So knowing those things, you need to know those things. And so basically, what is the value of cosine of pi, which is -1? So you want to run cosine of 0 through here. Cosine of 0 is equal to 1. Okay, so right here, so it's the x values at these points. I should have put that in there. Again, not going to spend a lot of time on it. So knowing that cosine of 0 is 1, you put that through all of this. And where does that match -1? And it is B. Again, I broke the rules. You're not supposed to choose x equals 0, but it does demonstrate, it does produce the right answer for you. Knowing these two things, the cosine of pi is -1 and then cosine of 0 is 1 based upon my choice of 0, which again is not supposed to happen, but it's the simplest thing. Choosing pi over 4 would be better, but that gets into even more complicated measures, but this does work to show the idea. So here you want to write down the product of 3 different positive integers is 48, and the sum of these integers is less than 13. What is the largest of these numbers? So I just wrote down, numbers that go into 48. That's what you need to look at. And so these are all the numbers. And so 3 of them should multiply to 48. That was my reasoning in writing these down. So 2, 4, and 6 are the 3. And then their sum is less than 13. What's the largest of the 3? That's actually a hard problem with just simple numbers. So you need to know, first of all, we are talking about numbers that go into 48, factors of 48. And then from there, you have to find the 3 and then add them to make sure that's right. Problem 17, here's another one that's challenging. So n to the 0 equals x. Anything to the 0 power is 1. Okay, that's set up by definition. There's a reason for that, which I'm not going to explain right now, but there's a reason for that. So x is 1. Knowing that, you come over here. It's a little bit hard to see. So you put that in, so n to the 3rd is 125. Then you have to know what number cubed is 125, and that is 5. Okay, problem 18, so they come right back at you with a simple one here. What's the greatest? So 14 minus 4 is 10, and then -6 minus 4 is -10. You do the absolute value. So absolute value represents distance from 0. It really means just to make whatever's in here positive, or if it's positive, keep it positive. So 14 and -6 are the 2 that work. So up here, you have a 45, 45, 90 right triangle situation. How do you know? Because this is all uniform, and this the fact that they throw this in here and twice, so they're just telling you that these are equal, so to speak. And so just based on the fact that you can conclude this is 1, you can also do the Pythagorean theorem to get the fact that these two are 1 to validate it. But so this ends up being a perimeter of 6. And that's the work if you didn't know the 45, 45, 90 right triangle rules. You can actually do this out to prove it. And then problem 20, here's the whole getting rid of fractions again. The SAT is psycho about this. So you have to think, anytime you come across this, what do I need to multiply through the entire thing, left and right side, to get rid of denominators? And so 4 and 5 go into 20, so 20 is that number. So how did you know that you had to do this? Well, and how do you know that you would get this? Just think of the smallest number you need to multiply by to get rid of those fractions, and all of a sudden this comes out. So multiplying to eliminate denominators is very important. And so in doing so, the right-hand side goes to 120, so 120 is the answer. Think of that all the time. They just seem to test it, 3 or 4 times in each section for sure. So this ends the no calculator part of the SAT first practice tests.